Do you have a confusion about quantum computing or what is quantum computers? How do they work? It's like magic but with science. Let's dive into the unreal world of incredible technology together, starting with the basics. So in this video, we are going to take a look at quantum computing and we'll try to understand what is quantum computing and quantum computing in general. Let's start with the basic, that is, what is quantum computing? Quantum computing is a type of computation that utilizes quantum mechanics to solve complex problems that are beyond the reach of classical computers. Now, classical computers includes computers that we use in our day-to-day life, which use bits which are either 0 or 1, that is 0 volt or 5 volt. So if a state is 1, it indicates that the current is passing. It's just like a switch. Let's try to understand what are classical computers before understanding quantum computers. So classical computers are based on bits. If you want to learn more about binary system, that is 0 and 1, you can check our binary video on our YouTube channel. But classical computers just work like a switch. You have a switch in your bedroom. If you press the switch, the light turns on. If you press the switch again, the light turns off. So that is, it is either 0 or 1. That is, either the light is turned on or turned off. This is how classical computers work, and usually the 0 indicates 0 volt and 1 indicates 5 volt, that is, the current is passing. Now let's try to understand quantum computers. Quantum computers or quantum computing is a type of computation that utilizes quantum mechanics to solve complex problems. Now, there is something called qubits. Quantum computers use qubits which can exist in superpositions of states. That is, they are both 0 and 1 simultaneously. This allows them to explore multiple possibilities at once, making it potentially faster for certain calculation. I'll give you an example in real world. In classic computers, you either can turn on the light or turn off the light. But if we talk about qubits, rather than normal bits, qubits can be both 0 and 1. That is, your light is turned on and turned off at the same time. Now let's try to understand qubits in simple terms. The basic information of classic computer is either 0 and 1, as we explored the example of light. But in case of qubits, the basic unit of information is in quantum computing is known as qubits. Analogically, a bit in classical computing has the ability to be either 0 or 1, whereas in qubit, it can be a superposition of states, that is both 0 and 1. If we talk about superposition, the ability of qubit to exist in multiple states at the same time and working parallelly, processing the same. This is called superposition. There's something known as quantum algorithm. You also need to understand what is quantum algorithm and how it works. Specialized algorithm designed to take advantage of quantum mechanics to solve specific problems, such as the Shesha algorithm for factoring large number and the algorithm used to unsorted the sorted database. Now let's try to understand the potential applications of quantum computing or applications of quantum computers. It can be used in various fields and especially in artificial intelligence, since artificial intelligence and AI models need accelerated training. It can be used to speed up and improve their performance. It can also be used in cryptography and developing new encryptions and encryption methods and breaking the existing one. Just imagine a complex task that cannot be done by normal classic computers. A superposition qubits can do it within few minutes, and this makes it easier to crack the algorithm, and cryptography can be a potential application of quantum computers. It can also work in the field of science by simulating molecular interaction to design new drugs and materials. Optimizing problem can also be a potential application, finding the best solution to complex optimized problem in logistics and finance and other fields. These were the potential applications of quantum computing. Now let's talk about the challenges while building or maintaining qubits or quantum computers. Building and maintaining qubits are really fragile and require extreme low temperature and isolation from the environment to maintain their quantum state. That is the superposition state between 0 and 1. Qubits are really fragile, thus they should be isolated from the environment to maintain the state. There is also a challenge of error correction. Quantum computation are prone to be errors. Every system has their own errors, and developing effective error correction technique is crucial and harder in case of quantum computers. Developing practical quantum algorithm is also a challenge. While some quantum algorithms have been developed, many more are needed to realize the full potential of quantum computing. Coming back to the summary, quantum computing is the field with the potential to transform any area of science and technology by harnessing the power of quantum mechanics. While still in its early stages, research and development and rapid advancement is still moving on, and thus the field is high to have a significant impact in the coming years. So that was quantum computing. My name is Priyank and you are watching Simply Explained.